Hello everyone, good evening. I'm sure that all of you have gone through that first part of the video for differentiation of parametric functions. So today we're going to just start with the exercise. Make sure that you go through how it is done, just to learn the basics how it is done. Otherwise it's just simple differentiation only, but the functions are slightly different. So all these exercises, all this new way, in short, in brief, we are just like learning new ways to differentiate different kinds of functions. So basically that's it. So I've discussed already that in the concept video for exercise 5.6. Go through it. And today, yes, we will continue with the solution of exercise 5.6. There are not many questions, about 11, 10 to 11 questions only, but I'm sure that it's going to take a long time because the questions are going to be big enough, because we have now like two functions connected by a parameter. So definitely it's going to take some time for us. But anyway, without wasting much time, let's just try to begin with the classes. So you can start off with question number 1. In the last video I've already done, so you can start off with question number 2. So yeah, welcome each and every one of you to this class where we will solve now today exercise 5.6. So I hope all of you have come prepared with your pen, books and paper. I hope all of you are on the table, not on the bed and resting and watching the video. Don't do that, okay? All right then, shall we? Chalo, let's begin. Yeah, good evening to all those who are joining. Let's begin. So exercise 5.6, question number 2. So the two functions that are given are a cos theta and y equal to b sin theta. So just one or two more topics left to be done in this differentiation. And soon, I am sure, soon we'll be starting off with a new chapter again. Okay. So with this kind of level of cooperation, definitely, yes. We see we are already finishing so many exercises one after the other. So that's all because, as I have always said during each and every classes, that's all because so many of you come and join the classes. That's why all this motivation comes up now. So anyway, let's just begin. So here, what is the parameter? Let's just identify it. Here, the parameter is, what is the third variable that is connecting these two equations? Theta, isn't it? So now let's one by one differentiate. This is going to be a small function. So differentiating both sides with respect to theta. So that is going to, a is a constant. You differentiate cos theta. We shall have, I'll just write directly, minus a sin theta. Then I'm just going to continue. Okay, let me just continue here itself. Y is b sin theta. So if we differentiate this with respect to theta, you will be having, come on, b cos theta. So now dy by dx, that can be written as dy upon d theta divided by dx upon d theta. So dy by dx, that's b cos theta minus a sin theta. So that in short, minus b by a cot theta. So that's just a simple question there for us. Sorry, the question was wrong here. Nobody told me also. That means you're not writing it down. Yes, somebody, Hilal is telling me b cos theta. Yeah, correct. So answer, of course, then in that case would be just simple, because if y is b cos theta, then derivative will be minus b sin theta. in that case dy by dx would be minus b sine theta. So sine theta, we can just cancel here. So yeah, the answer would be minus minus plus. So that will be just b by a. Sorry. Yeah, Hilal, you informed me. Thank you for that. The next question, that is, I'm not going to write down the question direct. You will anyway. Let me just write down what's there in writing in the question. Sine theta, sine t, the value of y cos 2t. So here the parameter is t. So now we will differentiate both sides. I'm not going to write down that part. That part, if you wish, you can write down, okay? Like differentiating both sides with respect to t. dy by dt equal to derivative of cos is minus sine 2t. And what is derivative of 2t? Differentiation of 2t is 2. So that can be written as minus 2 sine 2t. Now we are already at the end part of differentiation, so I'm sure that all of you can do this properly, easily, I mean. So dy by dx, so now dy by dx will be dy upon dt divided by dx upon dt. So that will be minus 2 sine 2t divided by cos t. This one we can expand to sine minus 2. Sine 2t is 2 sine t cos t divided by cos t. So cos t we can cancel. We will have minus 4 sine t. Alright, moving on to number 4. Okay, that's a simple question. For t, and the other one is 4 by t. So again, the parameter is t. So x is 4t. So derivative of x with respect to t, that's simply 4. Y is 4 upon t. So derivative of y with respect to x will be 4. We know the derivative of 1 by t is minus 1 by t squared. I will very soon give you another material, a video on the shortcuts. Not exactly shortcuts, but the usual daily things that we do in differentiation. No? So there I will be giving you all the small things that we usually need, like derivative of 1 by t and all those other terms. So that will be very helpful for you, okay, to just quickly jump into differentiation and then save you some time. All right, so very soon I'll be giving you that video also. You can check that video also. Alright, let's move on to number 5. Now questions will get bigger slowly. Cos theta minus cos 2 theta. Alright, so you can just write down, let me not write down that. I'm just going to start with the equations derivatives directly. So I can write down here the parameter is theta, isn't it? Yes. So you can write down here the parameter is theta. Written. After that, so if you wish, you can write differentiating both x and y with respect to theta. If you wish to write, you can write that also. Without that also ho jayega, but still then if you wish to write, you can write down. And now I am going to start with the differentiation directly. Okay? So differentiation of cos theta is minus sin theta, minus derivative of cos 2 theta is minus sin 2 theta, and derivative of 2 theta will be 2. I hope that's fine. So minus sin theta plus 2 sin 2 theta. And the function y is sin theta minus sin 2 theta. Sin theta minus sin 2 theta. So again, derivative of y with respect to theta would be, derivative of sin theta is cos theta minus derivative of sin 2 theta, that is also again cos 2 theta, but chain rule follows. So derivative of 2 theta will be 2. So that will be cos theta minus 2 times of cos 2 theta. Okay. So dy by dx would be dy upon theta, derivative of x with respect to theta. So that would be, I'll just arrange and write down. So 2 sin, no, y, y. So that's like cos theta minus 2 cos 2 theta dx, yeah, this one. I'll just arrange 2 sin 2 theta minus sin theta. So yeah, a small question only, this one also. Number 6. A theta minus sin theta and y as a 1 plus cos theta. So this also will be an easy question only. So you can write down now, here the parameter is theta. Here the parameter is theta. Differentiating both x and y with respect to theta. So chalo, after you write down the function once again, so a constant, so no need to differentiate that. Theta 1, no, differentiation of theta is 1, with respect to theta will be obviously 1, minus derivative of sin theta ho gaya to cos theta, bas nothing much. And y equal to a, what is the function, second one? 1 plus cos theta. 1 plus cos theta. So this one also differentiating with respect to theta, a plus 0 plus cos theta is minus sin theta. So that will be minus a sine theta. Now a we can cancel. But this is not the textbook answer that we have. I think we have about something like minus cot of theta by 2. No problem. We will have to now go back to trigonometry and recollect some formulas. You remember sine 2 theta formula? What was it? 2 sine theta cos theta. And do you remember 1 minus cos theta formula? 2. Anyway, multiple angles. So cos 2 theta was 1 minus 2 sine square theta. So 2 sine square theta is 1 minus cos 2 theta. So when you go for the submultiple angles, that's like half angles. I think I've told you how to remember it. All you have to do is divide, no, just mentally. Just for our remembering, just for quick recollection, no, because every formula cannot be recollected by us. So you just have to remember the multiple angle formulas, and when you want the submultiple angles, that's the half angle, sometimes we call it half angle formulas. A trick that will do wonders to you, divide the angles by 2. So if I divide the angle by 2, I'll have theta, now dividing by 2. Here I will have sine theta by 2 cos theta by 2. This is a trick that I generally use to remember the half angle formulas. And here also what I'll do, these are like multiple angle formulas, no? So here also I will divide the angles by 2, So I'll have 1 minus cos 2 theta divided by 2, 2 cancel, so we will have theta. So you see, it's that easy and simple and easy to recollect the formulas. Oh yeah. So I'll continue. You can write this in your rough copy. By the side. So minus sine theta, I will write as minus 2 sine theta by 2 cos theta by 2. Only the angle is divided by 2, okay? And 1 minus cos theta can be written as 2 sine square theta by 2. So 2 cancel. Sine theta, 1 sine theta by 2 cancels. I will have minus of, cos theta by 2 divided by sine theta by 2. So cos theta by sine theta is cot theta. So that will be cot of theta upon 2. So this is my derivative of y with respect to x with the help of parameters. Good evening, all of you. Good evening, Sunjumi. Cynthia. There are some more names which I don't remember, like you. No, Sanchitan. Okay. Good evening. Okay. So let's move on to the next question. That's like number 7 now. From here, I guess we'll have big questions now. So you can easily identify the parameter, I believe. So you can write down. I think it's t, isn't it? Yes. So you can write down here the parameter is t. Here, the parameter is t. So differentiating both x and y with respect to t. So the value of the first function is sine cube t divided by root over of cos 2t. So here when we start differentiating with respect to t, I have just one option, that is I'll have to use now quotient rule of differentiation, that is u upon v. Okay, I'll have to use now quotient rule. Do you remember the quotient rule? Let me just write down that once again for you. U upon v is, what was it? V square, v into u upon x minus u, derivative of v upon x. So, okay, so let's start. This is going to be a lengthy one. So v square, so that is root over of cos 2t whole square. Then v into derivative of sine cube t minus, that's why I have been telling you, no, you have to be now ready to just go for the derivative without some of the steps, because if you keep on writing down the steps everywhere, you will have a long question to solve. Now derivative of sine cube t, that is like sine t whole cube. So I'm going to do it directly. So that's going to be like 3 sine square t, and again derivative of, see, that's why I've been that's why I'm telling you now. Chalo is बार लिख देता है. चलो. Let me just write down this thing. This is with respect to t. You can kindly check the previous questions. Okay, I might have just made that blunder, a small mistake maybe. I do not know, I don't recollect, but here I recollected that mistake, that's why I'm saying. So we are differentiating with respect to that parameter, with respect to t or that theta. So I must have just written x only everywhere. So kindly check those few questions, and if necessary, please do make the corrections. It must have just slipped out of my mind, careless mistake. So because we are differentiating with respect to the parameter theta, isn't it? And this is 1 by root over of t, that's 1 by 2 root over of t. I think I gave you the formula for that shortcut. Derivative of t cos 2t. Okay, so I hope you've understood now, so kindly make that correction. Since we are differentiating it with respect to the parameter in the previous questions, I might have just written dx everywhere, derivative with respect to x everywhere, but in none of the functions our parameters are x, our parameters are somewhere theta and somewhere t. So just the mistake that I was doing here, I might have written x everywhere. So please make that correction. Especially so far we should not be differentiating with respect to x, we are differentiating with respect to the parameter only, isn't it? So can you make that correction wherever the necessary parameters, if it is theta with respect to theta, if it is t with respect to t, the way I'm doing it now. Okay, I hope you can do that, my dear children. Please do that. Okay, cos 2t, this will be root over of cos 2t, this will be so the sine square t, then chain rule, derivative of sine t would be cos t let me just combine so that it will shorten a little bit. Sine cube t divided by 2 root over of cos 2t. Differentiation of cos 2t would be minus sine 2t, again chain rule, divided into 2. Okay. So this is like whole divided by 1, because we have this by this, you have a quotient here also. So I'm going to take the LCM now. So the common LCM will be, okay, 2 I can cancel here, no need to write. So common LCM will be root over of cos 2t. So when you take the root, class 12 standard, I'm sure you can understand. So root, you'll have cos 2t into 3 sine square t cos t minus into minus, that's plus sine 2t sine cube of t. So rewriting that once again. So इसको यहाँ नीचे, so you'll have cos 2t root over of cos 2t. Let's see if we can just make some more arrangement. Just now I gave you the formula. So cos 2t can be written as 1 minus 2 sine squared t. I'm just trying to group, have a common group. 3 sine squared t cos t plus sine 2t sine cube t. So we should be having 3, simplifying this, 3 sine squared t cos t minus 3 2s are 6 sine power 4 t cos t plus sine 2t sine cube t. Power 4. Look here. Can we just write this as 2 sine t cos t? So that I will be having 2 sine power 4t cos t. Actually, after looking at this, no? All divided by cos 2t root over of cos 2t. So with that done, we can now, I guess we will not further simplify because we need to know what the other equation is also. So let's go 3 sine square t cos t minus 6 to 4 sine power 4 t cos t divided by cos 2t root over of cos 2t. Of course, we can write, we can do follow that also, right? Equation 1. So that is the first derivative. So let me write it down because I'll be rubbing it off. So I also need that to proceed. No? So you can also write it down. I'll write down this equation. You know, I have a tendency to forget. 3 sine square t cos t minus 4 sine power 4 t cos t cos 2t cos root over of cos of 2t. Okay. Alright, now finished? Okay, so we have already reached the half an hour mark today without knowing. Anyway, so yes, what now? Time for what? When we reach the half an hour mark, what do we do? Time for? Yes. Time for a glass of water. And those, actually, I encourage you to drink water, okay? Because maybe I'll become the brand ambassador of water. It will refresh your brain. Your brain will be more active also. It's very good during studies. Do not drink excess of water, but you should keep on sipping water. Otherwise, they will, your brain might just freeze also sometimes. Boof. All right, let's move on to the second function. That's y. Cos cube t by root over of cos 2t. So almost similar. So let's do this quickly. This one I've just done drag, okay? Because first one we've already done. Huh? Yeah, I keep on. I might make that mistake. Please, you don't do. Okay, getting getting just used to dx. So that's why it's actually dt. This is also dt. Yeah, t. Okay. So dy by dt I wrote. I guess I did not. I hope I did not write dy by dx. Kindly check that last equation number 1. I hope I've written dy by dx, not dy by. I hope I have written dy by dt, not dy by dx. Kindly check if it's dy by dx, that x, correct that to t. It has to get out of my brain. Okay. So again taking the yeah. So again taking the common LCM. Root over of cos 2t, here we'll have minus 3 root LCM cos 2t, 3 cos square t sin t, minus into minus plus sin twice of t cos cube of t cos 2t. So last time I converted the terms to sine. This time I'll try that to cos. So cos 2t root over of cos 2t. So we'll have 3 cos 2t. Yeah, this one also. We can write it as 2 cos square t minus 1. I think this 3 has been written 2 times because this 3 should not be coming from anywhere. No? 3 cos square t sin t plus sin 2t 2 sin t cos cube of t. So minus 6 when you multiply. No? So minus 6 cos 4t sin t, minus into minus plus 3 cos square t sin t plus 2 sin t cos or 4t cos 2t root over of cos twice of t. It's almost done. So dy by dt, not s, should be cos twice of t root over of cos 2t 3 cos square t sin t. This would be minus, same term, no? Minus 4 sin t cos power 4t. All right, let that be equation 2. Done now. Okay. So you can just write something like this using equation 1 and 2. Dy by dx would be equal, yeah, this time x will be equal to dy by dt upon dx by dt. So it should be something like this. Okay, so you can just check those 1, 2, 3, 4, the first 3, 4 questions. Kindly convert that to dy by dt, please. Okay. Chalo. Now, I'm a lazy person, so I'm going to do the lazy thing. Ready? Okay, finish. Okay, so that would be, see, dy by dx I have to write, so I'm just going to use this. And dx by dt, one thing that I remember was the denominator was this, because the denominator was same for both the functions. Numerator only I have to check now. Numerator was 3 sine squared t cos t minus 4 sine power 4t cos t. Sin t cos t can be taken common from both the numerator and denominator. So I'll have cos sin t cos square t actually. So I'll have 3, only 3 minus 4 cos square t, and here I can take sine square t cos t. Then I'll be left with 3 minus 4 sine square t. I think that's all right. Anyway, let's just do as it goes. Okay. Okay. I should have. Anyway, let's take the. So 1 sin t cancel, cos t. So I'll be having here cos t, 3 minus, okay, I do not know what is the answer to this, but I can sense something. Okay, something like 3 cos t minus 4 cos cube t, 3 sin t minus 4 sin cube t. Okay, so if you have your trigonometric formulas, can you just check once? If I'm not mistaken, this is dy by dx. If I'm not mistaken, trigonometry, there is one formula like cos of 3t. Cos 3t, and we have for sine of 3t. T or whatever we, let's say theta also, doesn't matter. Angle doesn't matter. So for cos, it's like 4 cos cube, that we can convert, 4 cos cube theta minus 3 cos theta, and for sine is like 3 sine theta minus 4 sine cube theta. Can you just kindly check once? Is it all right? Yeah, I think so. So with that, I'm sure we can make some changes. That is, with using this, just here only. So if I just take minus common, it will become 4 cos cube t minus 3 cos t divided by 3 sine t minus 4 sine cube t, and that can be written as minus cos 3t divided by sine 3t. Okay, so that means dy by dx is minus cot, finally, minus cot 3t. Baap re baap. Oh yeah, big question this one. Moving on to the next question, 8. A cos t log tan t by 2. So if you look at the question, you will see both the parameters are t. So yes, definitely you can write down let the parameters be t. I mean here the parameter is t. So differentiating with respect to t. So I'll begin dx with respect to t. That will be equal to a minus sine t plus log of tan t will be 1 by and derivative of, okay, in the exams you can just skip all those steps. Okay, this is like just in case if you just for your reference only, I'm writing so many steps. Okay, the first one. So cos t 1 we can cancel, so we will have 1 by 2 sine t by 2 cos of t by 2. You remember this formula? Just I think the one of the questions we have done this, so I'm going to do it directly. That is sine 2 theta. I think question number, just the previous question we have done this, use this formula. Multiple angles are multiple angles, you remember, right? I hope you have written it down also. You're supposed to write down all those notes. Whatever small notes that I'm giving you, you should be writing it down just beside the question, because that's why those formulas are needed in that question. So every time, whenever you do a question, you cannot go on flipping pages. No? So 1 minus sine square t is cos square t, but so I'm writing it, I have done it directly. Let's leave it here only because we have the other equation also, so we do not know what we're going to get from that other equation, right? Okay. So I think the second function is a simple function, no? Second one was y equal to a sine t. So y with respect to t will be simply a cos t. So now dy by dx using equations 1 and 2, dy by dt by dx by dt. So y by t is a cos t upon a cos square t divided by sine t. So a can be cancelled. 1 cos t, 1 cos t. I'm going to do it directly. 1 cos t, 1 cos t cancels. Sine this and this cancels. 1, 1 each. Sine t will go up. We will have sine t divided by cos t. So the answer would be simple. Tan t. Chalo, next. That would be next would be question number 9. So almost there. A sec theta. Let's finish it quickly. So I can write down the detailed part. You write it down on your own. Okay. Here the parameter is theta, differentiating with respect to theta. No, first. So dx by d theta will be equal to a. Differentiation of sec theta is sec theta tan theta. Maybe we can simplify this. That is a into 1 by cos theta into sin theta by cos theta. Because the other function is tan theta. So tan theta. Chalo, let's leave it like that only. In the last we will simplify. So let's let it be as it is. And y is a tan theta, if I'm not mistaken. Chalo, so dy by d theta would be equal to y is b tan theta. So that's b, derivative of tan theta is sec square theta. So now dy by dx, that is dy upon dt divided by dx upon dt. If you wish, you can write down here also like so, using 1 and 2. It's up to you. A sec theta tan theta. So 1 sec theta will have b by a into sec theta by tan theta. Now sec theta by tan theta, 1 by cos theta, tan theta is sin theta by cos theta. Got it, huh? Sec theta is 1 by cos theta, tan theta is sin theta by cos theta. So cos theta gayab, b by a into b by a, 1 by sin theta is come on, yeah, class 12, so आराम से these things we can easily do. Cosec theta हो गया. चलो, last second question, almost done. Number 10. Cos theta plus theta. So the formalities you write down. Okay. Here the parameter is theta, differentiating with respect to theta. Here, of course, I'll have to again apply product rule, theta into sine theta. So that's going to be okay. This one I'll write down. Okay, for you. Y a sine theta minus theta cos theta. And this one I'm not going to. चलो लिख ही देता है क्या है. As long as you understand, I have no problems. I have no problems writing more. Only when it's not necessary that time. No? Oh yeah. Done? All right, we can get ready with the last question. So you have two functions, that is a as root over of sine inverse t and y as root over of a power sine cos inverse t. Good thing is that you have to show that dy by dx is minus of y by x. There are 3-4 different methods in which we can solve this. I will choose the smallest and the easiest for you, since you have been so patient, my dear children. So I'm going to make it very simple. All right, so it's an interesting question, so you see how it can be done. Okay, very interesting. I'm doing this because basically in the question they are just telling us to prove dy by dx equal to minus of y by x. So what we will do now is, look here, very interesting question. Like what I'll do is x into y I will multiply. So what shall I have? So x into y will be under a common root. Of course, we can start in the usual way also and then go on differentiating. Yes, we will get the answer. No problem with that. But I would prefer this method because this will be, very simple. Okay, you can compare that by trying it with the other methods, the usual method, normal method. Okay, just picking up each function individually and then just going on differentiating. You can try that, and you can just have a look at this also. You will see the difference. Yes, well, for that, of course, we need a small concept that comes from chapter 2, that is the inverse trigonometric functions. So I'm going to need that concept which states or which gives, oh yeah, finished. See, what we get is this one. Sine inverse theta plus cos inverse theta is pi by 2. So this is a theorem that we get from inverse trigonometric functions. So we will make the most of this theorem in this equation, that is x into y now can be simply written as a power pi by 2. Of course, do write down this one also, since okay, that will be very much better. हो गया तो बस. Now kindly write down differentiating with respect to x. Differentiating with respect to x. So here product rule chalega, but anyway, what will be this, my dear children? This will be under, because this is a constant, no? Under. Derivative of a constant is 0. बस हो गया तो आराम से. So that sums up even the parametric functions also, exercise 5.6. Actually, we have some other functions to be differentiated also, derivatives of infinite series, but it's not included. So maybe some other time, some other topics, I will introduce that topic to you also, because yes, definitely those topics will be required for the JEE preparations. Okay, so we cannot ignore that. All right, but as for the textbook goes, that's how it is. I mean, that's it. Because the next topic is second order derivative, so that's almost the end of differentiation. But there are some functions, so it will depend on you. So if you need, short videos on those topics also, please do let me know, because yes, they are included in the JEE syllabus. It will be there. Differentiation, different kinds of functions. So if you need that, do let me know in the comment section below. Not now, later on. Okay, do let me know in the comment section below. If you want me to make videos on that, I will do that. Okay, so fine then. Thank you so much for being there every day, every time. All right, and because of that, differentiation भी almost खत्म ही हो गया. Okay, so I love you all. Okay, thank you so much. I love you. How do we say that like this? I love you all. Is it good enough, this one? Good enough? Isn't that looking good, no? All right. So thank you so much. I'll see you in the next class. Okay. Take care. Stay safe. Study well, my dear friends. All right. Okay. Love you all.